So let's learn 11.4, which is basically which button do you push on the calculator? Yeah, for real.
I know, right? It might be wise to bring a calculator.
Gather around, children.
Okay, so there are three things. There's an ln of x button on your calculator. There's a log of x button, and there's probably not, but maybe, a log base something of x button. Okay? This one probably doesn't appear on your calculator, and yet is the one we've been using, right? Like, this guy is the one we know and love, but not on the calculator. Some calculators have a nice dedicated button for this. The TI whatevers don't. So what we need to know is, what do the two buttons on my calculator actually mean? They say this, right? Which makes me think they're related to that. But in what way? So what's this guy missing?
The base.
It's missing a base, right? So obviously they're assuming the base is something. And on this guy, a similar thing. This is a log, and they're assuming we know the base for it. You guys want to do a little social engineering and look at a calculator and figure out what's going on there? There's a picture of a calculator over here too, right?
I can't even find it.
So there's a log and an ln button on the left-hand side. Remember, those things undo some other function, right? Remember that? This guy, log base b, this thing undoes b to the x, right?
10.
How do you know this one's 10?
Because I plugged in 10 and it said 1.
Oh, that's a good way to do it. Alternatively, a little social engineering will realize that by the log button, in yellow there's printed 10 to the x, right?
Yeah.
So whoever set up your calculator seems to think those two things are at least a little bit related. The reason they think they're related is that they're inverses. So when you see just a plain log, what they mean is base 10. How about the other one, this ln thing?
E?
Yeah, that's a base e.
What?
What? Good question. What? So this thing we need words for first. Does anybody know what we call this?
Natural log?
Nice. Yeah, this thing's called a natural log. Why is it called the natural log, and why does it have e as a base?
That's a great question, Joe. Why don't you tell us?
Because e is a super convenient number. It's this number that lets us say things like the rate of change is proportional to the population. Whenever we say something like that, we're talking about an e to the something function. Okay? So that's where this comes up naturally, right? Because the rate of change of a population is proportional to the size of the population. Does that make sense? The number of new geese, right, is proportional to the number of old geese. Right? That makes sense. Because it takes two old geese to make a little clutch of 6 new geese. Right? You guys see that? So the rate at which new geese appear is somehow proportional to the amount of geese that are already there. That's this thing. And the reason we call it natural is that it happens naturally, right? This is somehow like the case that we look at most often. Where does this guy come in? Why is 10 the other special one?
Because we use base 10 in numbers.
Yeah. This is basically amounts to, this is how many fingers you have, and so this is the button on your calculator. If human beings all had 8 fingers, then we would probably have log base 8 on the calculator. What?
We do have 8 fingers.
Oh, and 2 thumbs.
Oh, come on. So this thing is actually a little bit more related than we've maybe made an effort to think about before. When we write a number down like that,
Science of organization.
what are we counting here? This is the ones place. So how many tens is that?
Oh.
What's this place? This is the tens place, right? So that's 10 to the ones in there. What goes in here?
10 to the 2.
10 to the 2. You guys see that geometric sequence? And the other way, it's, what's this guy? Those are tenths, right? 10 to the -1. These are 10 to the -2. So the fact that we count numbers this way really means that this is kind of a natural extension. You guys want to see an easy example of that?
Sure.
Yes.
Fine. Let's estimate log of 103. Just ballpark this for me.
10 a little bit.
10 to the 2.
Yeah, 2 in a little bit, right? This is basically 2. Why is this basically 2? Yeah, because 103 is about 100, and 100 is 10 squared, right? You guys see that? So this is more or less log of 10 squared. And what does log do? Well, it asks how many 10s did you multiply to get that number? So here I multiplied 2 10s, so I got 2 out. You guys all see that? This makes estimating, right, this base thing, makes estimating logs of numbers nice. Because I can just count how many decimal places it is. Can I see another one? What if we were wanting to estimate log of 872, 745, 351? Here's some horrible number, right? I want to estimate this. You guys know scientific notation yet?
I definitely remember it.
Should we recall that a little bit?
10 to the 9.
Yeah.
So let's think about this as log of, what does this thing more or less start with?
8 or 9.
Yeah, maybe closer to a 9, right? And then how many tens are there? You guys see that? So if I call this a 9, then there's 1, 2, 3, 4, 5, 6, 7, 8 more places, right? So this is more or less the log of 10 times 9, or sorry, 9 times 10 to the 8th. That's really what scientific notation is good for, right? This gives us a nice, concise way to talk about really, really enormous numbers. Lots of zeros, right? So what I mean by this is 9 and then 8 zeros. You guys cool with that? There's your refresher on scientific notation. Now, what's this log about? Like, could I guess about how big this thing is? Yeah, it's somewhere between 8 and 9, closer to 9. Why don't you guys punch that into your calculator, see what you get? It's okay, it's only 10 button presses, right? Because you have a log button.
Which one?
8.940887544.
8 point something,
8.94.
right? So if we went to the calculator, we'd get 8.94. That's pretty darn good, right? Pretty close to 9. You guys see this? Questions, things? Concerns on this? Okay. This is roughly what I want you to know. This thing doesn't have a button, right? At least conveniently. So from here on out, we're going to use these two a lot more often because we have buttons for those two. Right? So we can get estimates.
Oh, nice. How'd you get to that?
You
Does that
push
make
the
sense?
math button, and then you go down a little bit.
So log base
Can you
7
take
of
that and
10.
scroll down?
Let's try that.
Sweet.
Which one of these is easy to punch into a calculator? Log
Yeah.
base 7 of 10 or log base 10 of 7?
This 10 is 7.
Yeah, this one, because I've got a button for this. You guys give me a number for this? Can you estimate this?
28.
Does that make sense? 0.84? Does that follow? Does it seem about right? How do you know it's about right?
It's gonna be less than 1.
It's going to be less than 1 because 7's less than 10. And it's going to be less than, or it's going to be
like
bigger.
more than a half.
I don't know. I don't know what square root of 10 is. Does that reasoning make sense?
Well, yeah, but
5 isn't halfway.
But if you're trying to make 10 into 7 and 7 is more than half of 10, you wouldn't have like a point. You wouldn't have 10 to the 0.5.
We should figure that out because it's actually a little bit off of what we think. So, you guys want to solve this for me? This is my concern, right? Is that halfway might not be at 5, and it isn't. It's a little bit off.
Square root of 10.
Yeah, this should be the square root of 10, right? Can somebody get the square root of 10 out of their calculator for me? But this is really a question about what's halfway between
3.16. There's a whole lot of numbers. But I'm not gonna-
yeah, no worries. So what's halfway between 1 and 10? Apparently 3.16. Is that a little bit odd? Yeah. It's halfway because I'm talking about halfway in terms of powers, right? Not halfway in terms of multiplication or addition. 5 is halfway between 0 and 10 in addition. Right? 5.5 is halfway in addition between 1 and 10. You guys see that? So you're going to have to readjust your thought about what halfway means here. Cool? All right. But really what I want you to take away is that this guy has a name, this ln thing. It's called the natural log, and it's log base e. And the other button, right, the plain log on your calculator is base 10. And it's only base 10. It's always base 10. If you see a plain log almost anywhere, it's base 10. If you want to check, you should plug 10 into it and hope to get 1 back out, right? There are 1 or maybe 2 computer languages where this log,
Yep.
the plain one, represents this thing, the natural log. So be just a touch careful if you're learning new computer languages. But other than that,
Use log 2.
what?
Most of the time computers use log 2.
I've never seen a language with log 2 hard-coded, actually.
They like 2s a lot.
Yeah, of course, right? When we're doing binary arithmetic, log 2 would be the natural choice, right? But I haven't seen one hard-coded. Usually they mean base 10 or natural log. You guys cool with this? Questions?
That'll be fun.
Okay.
Just playing with